All right, solving trig equations. Okay, so we want to solve the following equations for theta, where theta is going to be somewhere between 0 and 360 degrees. Give your answers in exact values. So when this first example, sine of theta is equal to 0.5, I'm going to change this to 0.5 to a fraction, just because it helps me find our angles better. So the first thing you want to do is look at your ratio and determine your reference angle to that. Okay, so I'm just going to sketch this. So my reference angle I'm going to get from my special triangles on my formula sheet. So it says sine of theta is equal to 1/2. So remember, this is opposite over hypotenuse. I'm going to go to my special triangles and I'm going to look for that ratio, 1/2. So remember, opposite over hypotenuse. Well, the opposite of 1 would be 30 and the hypotenuse would be 2. So this ratio of 1/2 would represent the reference angle of 30 degrees. So this gives us a reference angle of 30 degrees. All right, so now I want to draw this on my coordinate grid to determine my actual solutions. So I'm going to go back to my equation, and it says sine of theta is equal to a positive 1/2. So I'm going to use my cast rule to determine which quadrants would my sine ratio be positive. Well, that would occur in quadrant 1. So one of my solutions is going to be the same as my reference angle. This would be my first solution for theta. But I'm also going to get a second solution, and my second solution is going to occur in quadrant 2, because in this quadrant the sine ratio is also 1/2. Because technically I can draw this same terminal arm with the same reference angle, but the rotation angle is going to be 180 minus 30. So my second solution would be 150 degrees. So these would be my two solutions. Okay. All right, moving on to B. 2 cos of theta plus root 3. Well, before we can do anything, we want to isolate cos of theta. So cos of theta is like a variable. It's like an x. So the first thing we're going to do is subtract root 3 from both sides. So I'm left with 2 cos of theta equals negative root 3. And then I'm going to divide everything by 2. So now that cos of theta is isolated, I am now going to look to determine my reference angle. So when you look up your reference angle, you never want to consider the negative. You're just going to consider the ratio. Remember, all the negative tells you is in what quadrants my solution is going to occur. So on my formula sheet, I'm going to look up root 3 over 2. Remember, this is adjacent over hypotenuse. So adjacent over hypotenuse. Adjacent would be root 3 over 2. The adjacent of root 3 would be the angle 30 degrees. Okay, so the reference angle to this would be 30 degrees. Okay, so just be careful now. We are looking for the solutions when cos of theta is equal to a negative root 3 over 2, and 30 degrees would occur in this quadrant, and that would give me a positive cosine ratio. So even though 30 degrees is my reference angle, it's actually not a solution in this case. So now I'm going to use my reference angle and draw this reference angle in the quadrants that this is true. So the quadrants when cos is negative would be in quadrant 2. So here's my reference angle of 30. So my rotation angle, my angle in standard position, would be 180 minus 30, which is equal to 150. My other possibility is this could be drawn in quadrant 3 with a reference angle of 30. So my rotation in this case would be from here to here. which would be 180 plus 30 degrees, would be 210. So my two solutions for theta, the angle in standard position, should be 150 degrees and 210 degrees. Okay, and then lastly, tangent of theta plus 1. So again, we're going to isolate that tangent of theta, move 1 to the other side of my equation. So I have tangent of theta is equal to a negative 1. Okay? And so technically, I'm going to put this over 1, just so that I have my opposite and adjacent here. So again, I want to find my reference angle to this. So I'm going to go to my special triangles, look up opposite or adjacent. So again, I'm ignoring the negative. I'm just worrying about the 1 over 1. So 1 over 1, opposite over adjacent, could relate to either one of these angles. So my reference angle in this case would be 45 degrees. Okay, so now I'm going to sketch this. I'm going to think about my cast rule. In which quadrants is my tangent ratio negative? So my solution should be in quadrants 2 with a reference angle of 45 and in quadrant 4 with a reference angle of 45. So my rotation angles, well, this rotation angle would be 180 minus 45, which works out to 135 degrees. And my second answer would be this rotation, which would be 360 minus 45, which works out to be 315 degrees. So my solutions to this would be 135 and 315.